going to start by graphing some angles. But before we do that, let's introduce a couple more vocabulary words. First word we've got is an oriented angle. An oriented angle has an initial side and a terminal side. The initial side is where the angle starts. The terminal side is where the angle ends. Now, we also want to define what direction we go. So we have said that if we go in a positive direction, we're going to call that counterclockwise. So anytime we go counterclockwise from our initial side, we say that is a positive angle. Then, if we have a negative angle, we're just going to define that as clockwise from the initial side. So if we start at the initial side and go clockwise rotation, we're going to call that a negative angle. Now this is really important because that means in this class, when I say we have a negative angle, that doesn't mean I have negative stuff. That negative is purely there to express direction. Because remember, an angle is a measurement of distance. It's the measurement of the rotation. Distances and measurements can't be negative. So we're not saying that this amount is a negative distance. We're just saying it's the same 60 degrees distance, but we're going in a different direction, which will be really important in this class. Anytime you see that negative sign on an angle, remember, it's not talking about a negative angle, it's talking about an angle in a specific direction. Now, along with oriented angles, we also need to talk about angles in standard position. We're going to start to graph angles on our coordinate graph. Here's our x-axis, here's our y-axis. Now, when we do this, we graph these angles in standard position, we always put the initial side of the angle on the positive x-axis. Always. Then the terminal side of the angle is what moves around. Then, to measure your angle, you go from the initial side to the terminal side. And that's the measurement of that angle. Notice that this angle has multiple measurements. If I go counterclockwise, that's a measurement of positive 120 degrees. If I go clockwise, that's a measurement of negative 240 degrees. The measurements are bigger on this side, and we say it's negative because it's clockwise, smaller on this side, and positive because it's counterclockwise. Those are what we call coterminal angles. They share the same terminal side. And we'll talk about those more as we go throughout this lesson. For now, just understand that if an angle is in standard position, its vertex is at the origin, the initial side is on the positive x, and the terminal side can be wherever. It's whatever measurement the angle is. So now that we understand how to graph an angle in standard position, let's come up and sketch these angles. So I have angle alpha. By the way, that fancy looking A is what we call alpha. It's a Greek letter. Basically, it's the same thing as if I had called it X, Y, or Z. It's just a variable. But for some reason, when we're labeling angles, we like to use Greek letters instead of normal English letters. Don't know why, we just do. So we call this one alpha. This is beta. They're the first two letters in the Greek alphabet. Either way, I want to come to alpha and I want to graph it. Now remember, I have this coordinate grid. My initial side is always on the positive x-axis. And then my terminal side, I want to be at 111.371 degrees. So to sketch this, we need to know some basic angles. I always start here, that's 0, that's my initial side. Now, if I go up to the positive y-axis, that's a right angle. So this is going to be 90 degrees. Meaning, if if I had an angle here, from the initial side to the terminal side would be a 90-degree angle. Now, if I went all the way around to the other side, that would be a straight angle, so 180. If I went all the way down, that's 180 plus another right angle. That gives me 270. And if I want to go all the way around and end where I started, that's a full rotation. That's 360. Now, these are things that you're going to be graphing almost every day this entire semester. So these are numbers you've got to get down and know. 0, 90, 180, 270, 360. You're going to know those like the back of your hand. You're going to do them all the time. So now that I have those drawn in, it's a little easier to see where 111 would go. 111 is going to be in quadrant 2. Now, just in case you've forgotten your quadrants, we always put quadrant 1 up here in the upper right, and then go counterclockwise from there. So this is quadrant 2, this is quadrant 3, and this is quadrant 4. And that's how we name them. So that 111 degrees is going to be somewhere in quadrant 2. Now, I know 111 is going to be closer to 90 than it is to 180. So I'm just going to sketch-ish where I think it should go. And then I label it from the initial side to the terminal side is going to be 111.371 degrees. And that's how I sketch this angle. So let's try and do angle beta. Once again, we start with 0. We have 90, 180, 270, 360. We have our initial side on the positive x. That never changes. Our terminal side, however, is going to go at 37 degrees, 28 minutes, and 17 seconds. So, what quadrant will this angle be in? Well, 37 degrees is going to be between 0 and 90, so this is going to be in quadrant 1. I know 37 will be closer to 0 than 90, so I'm just going to sketch out where I think it will be-ish. Then I go from the initial side to the terminal side, 37 degrees, 28 minutes, 17 seconds. And there's my sketch of approximately the measure of rotation of this angle. Now that we've kind of measured these angles out, let's talk about supplementary and complementary. Remember, supplementary means that it should add up to a straight angle. So here's my straight angle all the way across. If I want it to be supplementary, then I'm looking for this angle, the angle that makes the rest of the way up to the straight angle. So the easiest way to find that is to do my straight angle minus the angle I've got, and that will give me this distance that is left over between them. So I go into my calculator, 180 minus 111.371 gives me 68.629 degrees. And these are the two angles that if I add them together, gives me that supplementary straight angle of 180 degrees. Now let's do a complementary one. Remember, complementary should add up to 90. So this time I'm looking for this angle to get me the rest of the way up to my right angle. So the easiest way to do that is to do 90 degrees minus the angle I've got, and we're going to subtract. Now this is a very interesting problem. Notice I specifically stacked them this time, kind of like old school elementary subtraction. And what I'm going to do here is I'm going to borrow the 1. Do you remember doing that in subtraction in elementary school when you had like 121 minus 17? And you had to do 1 minus 7, so you'd borrow the 1 from here and put it there. So you'd have 11 minus 7, which would be 4, and then you'd keep going from there. That 1 minus 1 is 0, carry the 1 down. Same thing here. What I'm going to do is I'm going to borrow 1 degree. So I'm going to change this to an 89, borrow 1, and I'm going to turn that into 60 minutes. Because I know that 1 degree is 60 minutes. So I borrowed 1 from here and carried it over to there. Then I'm going to do that again. I'm going to borrow 1 from this minute, turn it into 60 seconds. Because I know 1 minute is 60 seconds. So I borrowed 1 from here, carried it over to there. And now that I've got something in each column, I can just subtract the columns. So 60 minus 17 is 43 seconds. 59 minus 28 is 31 minutes. And 89 minus 37 is 52 degrees. And that is my complementary angle. That's how much this angle is to get it up to my right angle. So we now know how to graph angles. We know how to find supplementary and complementary. We know about oriented angles and standard position. Let's do one more problem in this video and then we'll move on to the next one. Now that we've talked about standard position and oriented angles, we can actually do angles that have more than one rotation. Let me explain what this means. I have my coordinate grid, just like we did before. I know this is 0, 90, 180, 270, and all the way back around is 360. However, I don't have to stop at 360. I can keep going around as many times as I want. In fact, let's graph 450. So remember, our initial side always goes there. That's always true. 450, I want to go all the way around the circle to 360. And then I want to keep going. So if I do 450 and minus the revolution I've done, that gives me 90 degrees left over. So I go 90 degrees more, and that is my terminal side. So 450 degrees is going all the way around the circle plus another right angle to get me to there. And we can do that for angles of any degree measure now. You just keep going around your circle until you end up where you need to end up. And this is another really good example of coterminal angles. In this case, we see that 90 degrees and 450 degrees share the same terminal side. So because they share the same terminal side, we would say 90 and 450 are coterminal. They're basically the same angle measurement. We just went around multiple times. Same thing with the positive 120 and the negative 240. They share the same terminal side, so they're coterminal. So in the next video, we'll explore this idea of coterminal a little bit more and do a couple example problems of it.